My name is Torsten Berning and I'm Associate Professor in the Department of Energy Technology at Aalborg University in Denmark. Our recent research has actually focused on drones. Drones are actually a very important upcoming applications. As we have just seen, for example, in California at the wildfires. Drones can help fight wildfires. A drone, of course, must fly for a long time and actually have a fairly high payload. A payload means this is the mass that the drone can actually carry on top of its own weight. And it's important to increase the payload, and it's important to decrease the price of drones. Ideally, we want to power these drones with green energy. And we know that fuel cells are actually a very efficient energy converter. So we're storing hydrogen on board of the drone, and we're using the air from the environment actually to have the hydrogen react with the oxygen to form the electricity that we need to power the drone. Now, a problem with this is actually that fuel cells are very expensive and they're heavy and bulky. What we want to do is reduce the price and the mass of these fuel cells. And our research basically has now shown that all we need to do is place such a cheap plastic grid costing around $1 in front of the fuel cell. The grid will then induce turbulence to the air that we're actually driving through the fuel cell. And this turbulent air will increase the heat transfer inside the fuel cell and allows us to go to higher currents, and we generate higher power density. In our experiments in our lab, actually, we have shown that we were able to increase the power density of these fuel cells by more than 30%, close to 35%, basically. And this, of course, corresponds to according reduce in cost and in size and mass of the fuel cell. So the drone can actually fly longer. We have also found that we reduce the hydrogen consumption while we're operating the fuel cell by some 20%, which directly means that we can basically fly the drone for 20% longer.